Good day, everybody. We are back again together, and this time to tackle paper 2, which is the chemistry portion of physical science. So I've taken actually the paper that was written in Gauteng. However, they wrote the November 2020 paper, the second edition of it. You remember there was that leak that took place. So just please subscribe if you haven't subscribed, okay? And for those of you who obviously need assistance with either physical science or mathematics, please don't forget to just give us a dial, and the email address is info@mlungisinkosi.co.za. So it's Heritage Month in South Africa, and we are celebrating heritage. Okay, so continue to to be proud about where you come from and who you are as a person. Right, as we do physics, let's get right into it. So I'm going to start with the organic chemistry portion today, and hopefully as we continue along together, we'll do all the other parts. Okay, so question 2. Let's see if you answered this correctly. And by the way, ladies and gents, the purpose why I do this, because I saw from some of the comments, people starting to become despondent, about how they answered the questions and so on. The point is not to make you feel despondent, but however, the issue is that you should just use this opportunity. I'm trying to teach. Obviously we've produced much content about this, what I'm covering today. And if you realize that there are still some areas that, are still lacking, maybe in how you answer questions and so on, you can go back to our previous material that we've already produced and start answering questions. Okay, so please don't use it as, something to gauge how much you don't know, but rather use it as an opportunity for learning. Okay, right, so let's get right into it. So we're given question 2. So they've given us all of those compounds there. Okay, so A to E. And, when I look at A, I can see this is a haloalkane. So there's a bromide there. And obviously we've got all of those chains there. And then we've got B, which we don't know. However, we do know that it's a hydrocarbon. Okay, we've got C, which has a C double bond O. So definitely, and this C double bond O, it's not in the terminal carbon, right? So we know this should be a ketone. Okay, and we've got D, and you can see at D there, we've got an OH. So this tells me that this is an alcohol. And finally, we've got E, which looks like a hydrocarbon, okay, with lots and lots of chains. And I can tell the number of carbons there are not maximum, so there should be a double bond there, okay. So yeah, that's how we're going to look at it. We're given a good mix of different structural formulae, right? We've got structural ones, and we've got condensed structural formula. So yeah, let's have a look at it. They say write down the letters that represent each of the following. So we want a ketone. So obviously when we look at a ketone there, that's going to be C. So we know that our answer to the first question, so 2.1.1, that's going to be C. And 2.1.2, sorry about that, let me just adjust it. Okay, so 2.1.2, they want a hydrocarbon. Okay, so hydrocarbons, remember we said C, we've got B there, and we also have E, so you can either use one of those. So B or E. Okay, you could have mentioned either one. And then what about 2.1.3? They wanted an alkene, all right? And as I indicated to you, of course, we couldn't tell whether B is an alkene or not, since we don't know what X and Y are. But this one I can definitely tell in this case, because you see there's not a maximum number of hydrogens there between those two carbons. So definitely this tells me this should be our alkene, right? Okay, moving to question 2.2. Okay, we're going to be very quick about this one. They say write down the IUPAC name of compound A, right? So when I look at compound A, let's see how many carbons do we have in our parent chain. So that's going to be, let's look at the longest one. Let's start there. So that's 1, 2, 3, 4. Okay, I'm going to say 5 and 6. So even if I went that way, 1, 2, 3, 4, 5, and 6, whichever way I look at it, okay, the longest one that I have is 6 carbons, right? So that definitely tells me that we've got the longest, or the parent chain, being 6. So that's 6 carbon in our parent chain. And then I am going to take, because it's a haloalkane, it means that we prioritize the bromide ion, right? So in terms of how we're going to number. So the closest that it is from the left, okay? So I'm going to say this is carbon number 1, 2, 3, 4, 5, and 6. Okay, if you wanted to, 1, 2, 3, 4, 5, and 6, really doesn't matter, right? So this is going to be 2 bromo. But I've got a side chain at carbon number 4, okay, or a branch, if you want to call it that. So I've got a branch or a side chain. So at carbon number 3, I've got a methyl group there. I've got a methyl group there. And I've got an ethyl group at carbon number, okay, so we took that as our 6. At carbon number 4, I've got an ethyl group, okay. So in this case, I've got bromine, I've got ethyl, I've got methyl, right? So let's start with, so we give priority obviously to letters of the alphabet, right? And if you don't know that, please go and look at our organic chemistry playlist, right? So that you can know how to name these guys. So I'm going to say, well, this is going to be at carbon number 2, I've got a bromide, so 2 bromo, okay? And I'm going to say, well, at carbon number, so after the B, the next one would be an ethyl, and that happens at carbon number 4, right? So I'm going to say this is going to be 4 ethyl, okay, right? And that's our side chain. And then I've got at carbon number 3, I've got 2 methyls. So I'm going to say this is going to be 3,3 dimethyl, okay, so that's 3,3 dimethyl. If you don't mind, I'm just going to continue over to this side, okay? It's because I've run out of space, but you must try and make it one word. And obviously now we go to our parent chain, which is going to be 6 carbons. So this is going to be hexane, okay? So there's no double bond, so we didn't need to call it any other thing, okay? Right, and then let's go to, okay, so this was 2.2.1. Let's go to the next question, 2.2.2. They say the structural formula of compound D, right? So in this case, we want to know what does compound D look like. Okay, you can tell there. We've got CH3 now. This bracket over here, and I think I've shown you this before. When they show us brackets mean one of two things, okay? Either brackets can be interpreted as a repetition, and how we'll know that it's repetition is that there's a number outside the bracket, like in this case there's a 2 outside the bracket there, so it means we are repeating CH2 twice, okay? But sometimes it also shows us a side chain, okay? A branch, right? So in this case it means I've got CH3, so it's going to look like that. So CH3, so those are the 3 carbons, okay, and I've got 2 CH2s, okay, so I've got a CH2 following that and another CH2. So if this was a branch, you'd see it would be CH3 over there, okay, but it would be in brackets, so it would tell me that it's actually a branch of the other carbon, okay? Right, hopefully we'll do a question like that sometime. Right, so that's CH2 twice, and then we've got a CH with an OH. Can you see that shows us that in this case that's our functional group? So we've got C with an H, but there's also an OH, okay, a hydroxide ion, okay, and finally we've got CH2, two hydrogens, okay, and finally we've got CH3. Okay, so this is what it would look like structurally, and yeah. All right, next question. They say write down the IUPAC name of the straight chain functional isomer of compound C. Now, I'll say this again. Remember, we've got two groups that are functional isomers of each other. So the first group is ketones are functional isomers of aldehydes, okay? And esters are functional isomers together with carboxylic acids. So this time we're looking at a ketone. So they want a functional isomer. So in this case, it's definitely going to be an aldehyde, right? And remember, they said they want the IUPAC name. Okay, so we're not looking for the structure, we're looking for the name. So how many carbons are there? 1, 2, 3, 4, 5. So it means it would actually be pentanal. All right. And please remember, with aldehydes, I would not need to number unless there's, a substituent onto it. Okay. The only reason I'd need to number is if there's something particular there, either a branch or whatever the case may be, right? But otherwise, I would not need to number. So that's 2.2.3. Okay, so it means it would be pent, okay? But in this case, it's not going to be pentanone. This would be pentan 2-one rather, or 2-pentanone. But this one is simply going to be pentanal. Okay, right. Remember, we would not need to put the number there because remember, with the aldehydes, it would always be at the first carbon. The functional group would always be at the terminal carbon, right? Okay, let's continue. So 2.3.1, okay, they say we've got compound B, which is a straight chain compound that undergoes the following exothermic reaction. Okay, so they give us that reaction there. Okay, right, I'm just going to move this a bit. Okay, so they give us that guy. There's our formula there. They say besides being being exothermic, what type of reaction is represented above, right? Okay, so whenever we find a hydrocarbon reacting with oxygen, right, we usually call that reaction combustion. Okay, so we can call this a combustion reaction. Okay, and so it's combustion is a reaction with oxygen. So sometimes they may also just call it oxidation, right? So I'm just going to stick to combustion. Okay, if you want to, you can also call it oxidation. And then they say 2.3.2, they say determine the molecular formula of compound B, right? So in this case, how we're going to determine that formula there is that we actually going to have to look at how the structure is there in terms of the number, the ratios, right? So if you look at it, you've got an X amount of carbons there, right? And in this case, we're going to multiply them by 2, right? So 2CX there. But how many carbons are there on the right-hand side? We've got 16 carbons. Can you see 16 multiplied by 1? That would be 16 carbons, right? So it means 2 times CX should actually be 16. So what should this number be? It should be 8, right? Okay, so it means that this is going to be C8 as 2C8. But what about Y? I've got 2 times HY again. Let's look at the number of hydrogens that side. I've got 18 times 2 there, which is, and that would be 36, right? So what would I have here? All right, so this would be also 2 times 18 to make it 36. So it means that X is 8, H is 18. So in this case, it means this would be 2.3.2. I hope that kind of makes sense in how I explained it. Okay, so C8, C8H18. Okay, so it's actually octane, right? This is the normal reaction that takes place in the combustion chamber of a car. All right, this is what makes a car to move. All right, well, if it has a petrol engine, obviously. Right, the very last question. They say the reaction above takes place in a closed container at a constant temperature higher than 100 degrees and at constant pressure, right? Now they say calculate the volume of gas formed in the container, okay, when 50 cubic centimeters of CXH18 react completely with oxygen. Now, the beauty about this question, why I liked it is that you would not be limited because they've given you the ratios there. You would not be need to know what CXHY is, right? Because in this case, so you wouldn't need the preceding question to answer the next question. So it doesn't disadvantage you in any way, right? So what you're going to do is, okay, for those of you who have not watched my videos on stoichiometry, ooh, shame. You've been missing out, right? So just please make sure that you watch those videos. I'm telling you, if you ever wanted to perfect chemistry, tell you those videos would actually make you a champion when it comes to chemistry, because what I do is that I unpack the nuts and bolts of chemistry and they'll help you quite a lot. Okay, so let's get to that last question. So we've got 50 cubic centimeters, and remember, for combustion to take place, this we call complete combustion. How do I know that? Carbon dioxide is a product. We have another type of combustion which is incomplete. So this is where you've got, it doesn't occur in excess oxygen, right? So what you get there as a product is carbon monoxide. But in this case, because we've got carbon dioxide, tells us we've got excess oxygen. What does that tell us? Tells us that it means that this reaction reactant rather, is actually a limiting reagent. It's the one that's going to determine how much product is formed. Now, all I'm simply going to say is that, well, my ratio says for every 2 of octane, I get 16 carbon dioxide, 16 moles of carbon dioxide, right? So let me write that down. So I'm going to say, well, for every 2 C8H18, and even if you didn't know what it is, you'd still write CXHY, right? You get 16 moles of carbon dioxide. Now, in this case, I can do this with volumes. Why? Because remember, because it's talking about volumes of gas, I know that the molar volume would be the same. So in this case, to calculate the number of moles of any gas, I would use the same molar volume. So it means that, sorry about that, I can actually use the same molar volume to calculate. So in this case, when I'm given volumes, I can actually just calculate using my volumes as though they were number of moles. Okay, right. Now, quickly, so we'd say 2C8H18 gives me 16. So the question is, if I've got 50 cubic centimeters of C8H18, okay, which is octane, how many moles, okay, I'm going to make that X, how many moles of carbon dioxide am I going to produce? Look at this. I put the same things on the same side. So 2 of that will give me 16. So 50 of C8H18 will give me an unknown amount. Why am I doing that? I'm trying to find out the number of moles or the volume of carbon dioxide, because they wanted the total volume of gas that will be formed, right? So all I do is just cross multiply, take the coefficients. 2 multiplied by x will give me 2x, all right? And in this case, I'll say equal to, and I'll say 15 times 16, that would give me 800. Okay, so, and if I divide both sides by 2, sorry, if I divide both sides by 2, I get, so the number of moles, or rather the volume of carbon dioxide, would actually be 400 cubic centimeters. Okay, right. So now let me try and continue over the other side. So now I know I've got 400 cubic centimeters of what? Of carbon dioxide that's formed. But now I need to find out what is the volume. Remember, these are both of these are gases, right? So I'm trying to find out the number of moles of, or the volume rather, of H2O. So I'll say, well, for every 2 CXHY, or you can say C8H18 because we know it now, I will get 18 moles of H2O, water, right? Because it's in gas form. So in this case, if I've got 50 moles of octane, how many moles of water am I going to find? Now, maybe just for the sake of confusion, let me call this X1, or you can call this V. You know, you're not obliged to call that X or whatever. You know, I just chose a variable for myself. Right, so I'm going to say, well, this is 2 times X, this is 2X1. Okay, will give me 50 times 18. Okay, let's get that quickly. So 50 times 18. Okay, I get 900. Okay, so divide again by 2. So it means that X2, sorry, this would be X2, would be 450 cubic centimeters of gas. Remember, what was the question? What is the total volume of gas? So in this case, it means that it would be the 400 cubic centimeters and the 450. Remember, those were your products. So in this case, it means that your total volume of gas that would be formed, okay, you're talking products, would be 400 plus 450. And in this case, this would be, oh goodness, my maths, 850 cubic centimeters of gas. All right, so I hope that made sense, ladies and gents. Right, and this is how we answered question 2. We're not going to waste time. We just simply are very clinical and very, very direct in our approach. Okay, so we'll come back again next time. I'll see you when it comes to question 3. I know most of you are rushing for that KC question, okay? We'll get to that slowly but surely. Otherwise, I'll see you guys next time. Please don't forget to subscribe, and please tell even more people about our channel, okay? Right, see you next time. Sharp, sharp.